So this is exactly the same format as the test. Let's look at the first one. So when we look at this, remember we have to show our work to make sure we understand what we're doing. So if I'm looking at this here, what I'm going to do is I'm going to bring the x's to the left and the numbers to the right. So first I'm going to add 50. Some of you guys may have brought the x over first, which would have been fine. If I add 50, I get 6x, this goes away, is equal to x. Negative 15 plus 50 is positive 35. Then I bring the x over by subtracting it. 6x minus x is 5x. That is equal to 35. You divide by 5 and you get x is equal to 7. Let's look at the second one. So when we draw the dotted line so we can see both sides, some of you guys like to just say, hey, I'm going to always bring the x's over to the left at first. That's fine. If you have x plus 81, you minus the x to bring him over with the other. 10x minus 1x is 9x. 9x plus 54 is equal to 81 because x minus x is 0. Then you look at it and you realize that you have to subtract 54 from both sides so that you can isolate 9x for now. 81 minus 54 is 27. And then you're going to divide by 9 and you get x is equal to 3. So, if you want to get all of your x's on the left-hand side, you're going to add 5x first, right? You add 5x to both sides, and you get negative 10. Negative 7x plus 5x is negative 2x. That is equal to negative 4, because I canceled out the 5x. Some of you might have started by moving the minus 10 over to the right. Either way, it's going to end up being correct. If I add 10 now, as opposed to at the beginning, you would get negative 2x is equal to 6, at which point then I would divide by negative 2, and you get x is equal to negative 3. Dotted line down the equal sign again so I know what side's left and what side is right. Now what I'm going to do is I'm going to actually move the numbers over first. It doesn't matter whether you move all your x's over first or your numbers over first, as long as you move the x's to the left and the numbers to the right. So if I did minus 2 to get rid of this 2 on that side, I would minus 2 from the 9 because they are the like terms. They're both constants. Don't forget that this one is really negative 7x is equal to 9 minus 2 is 7, and you rewrite the minus 8x. At this point, you realize, hopefully, that this term is on the wrong side. I want the x's on the left, so in order to get rid of a minus 8, I am going to plus 8x. And whatever you do to the right side, you do to the left. Negative 7x plus 8x is 1x, or just x, it means the same, equals, bring down the 7. X is equal to 7. The first one, what we're going to do is, again, draw a dotted line. Now, I recommend that if you're still getting a little stuck, you just get yourself to get all the x's on the left and all the numbers on the right. By looking at this, you would notice that this x is on the wrong side because you want him here. So to get rid of a minus 2, because you always take the sign in front, you plus 2x. But when you add the 2x to the left side of the equal sign, you have to line it up under the other x variable term. 42, nothing happens, so you rewrite it. Negative 9x plus 2x is negative 7x. That's equal to 49. Negative 2x plus 2x is 0. It just cancels out. Now we look at it and we understand that we want x's on the left, but this 42 needs to go over to that side. So we're going to subtract 42 because it's currently a plus. And if you want to get rid of a 42, you minus 42. And when you minus 42 to the right, you get 7. And you get negative 7x is equal to 7. Divide by negative 7, x is equal to negative 1. Again, we separate both sides of the equal sign just so that we could see where things go. I want all my x's on the left and all the numbers on the right. Plus 4x to move him to the left. When I plus the 4x, I make sure that I line him up underneath the other x term. The 24 just gets rewritten. What is negative x plus 4x? 3x. It's positive 3x. Equals, the 18 is still there, and negative 4x plus 4x is 0. It just goes away. Now, as I look at this, I notice that I still need to move the 24. So I'm going to minus the 24 so that he's on the other side with the other constant. You get 3x is equal, 18 minus 24 is negative 6. When you divide by 3 to both sides, you get x is equal to negative 2 because negative 6 divided by 3 is negative 2. So with this one, again, if you want all the x's on the left, I'm going to plus the 6x, and I'm going to line it up under the minus 9x. You rewrite the 12. Negative 9x plus 6x is negative 3x. That is equal to 3. I'm going to minus 12 to both sides. I'm going to rewrite the negative 3x is equal to negative 3 minus 12 is negative 9 divided by negative 3, and you get x is equal to a negative divided by a negative is a positive 3. Dotted line. I'm going to add the 5x to bring him over here, but I'm going to make sure I line it up underneath the other x guy. I rewrite the negative 12. I think in my head, if I have negative 3x and I add 5x, I'm adding more than I'm subtracting, so it's going to be a positive 2x is equal to negative 4. Now I'm going to add 12, because that's the only way to get rid of a minus 12 is to plus a 12 to both sides. And you get 2x is equal to 8. And you divide by 2, and you get x is equal to 4. We're going to start with this one just to make sure we're covering all of the different types. A rectangular block of land, so in my head I picture a rectangle, is 5 meters long and 3 meters wide. Make sure you read the whole question. Don't assume that you're asked for area, because it says a fence is to be constructed around the perimeter. What is the length of the fence that goes around? Well, I'm just going to add 3 plus 5 is 8, plus 3 is 11, plus 5 is 16, so it's 16 meters. Number 14. An outline of the block, blah, blah, blah. What is the perimeter? Perimeter is distance around. So the distance around would be 23 plus 36. And 23 plus 36 is 59. Plus an extra 53. So we add 53 to that. Is 112. And then 112 plus 20 is 132. And the units are just meters because it's perimeter. So for number 9, if you divide both sides of the equal sign, remember if it makes it easier for you to think of getting all the x's on the left and all the numbers on the right, it means that as you're looking at that, you're going to want to bring the 7x over to the left. So that means that the minus 7x becomes plus 7x. You would rewrite the negative 5. Negative 8x plus 7x is negative 1x equals negative 1. It's very possible that you might have started moving the numbers, the constants, over first. That was fine. Either way, you're still going to get the right answer. Now I'm going to bring that minus 5 over by adding 5. You get negative 1x is equal to 4, so x is equal to negative 4. With this one here, again, dotted line down the equal sign so you could see both sides. The 2 is being distributed to the x minus 5 through multiplication. You write 2x minus 10, rewrite it, is equal to x plus 2. If I want all my x's on the left, I might start off by bringing that x over by minusing it. 2x minus x is x, because it's 2x minus 1x basically. Rewrite the minus 10 equals 2. From this point, you want to get the x's alone, the numbers on the other side. So instead of minus 10, you're going to plus 10. There's the dotted line for the equal sign. That gets you x is equal to 12. Same thing, you're going to distribute the 5 to the x plus 4, and you get 5x plus 20 equals x minus 12. Now we're going to separate both sides of the equal sign. We want all the x's on the left, so that x on the right is going to be minus, so we can bring him over. That makes the x go away. You get 5x minus 1x is 4x plus 20 is equal to, always take the sign in front. That is negative 12. You must bring that down with his sign. Now you're trying to get rid of that plus 20. And so what you're going to do is you're going to minus 20 to both sides. That makes the 20 go away. You're left with 4x is equal to negative 12 minus 20 is negative 32. Divide by 4 on both sides. X is equal to, a negative divided by a positive is a negative, and 32 divided by 4 is 8. This one is a little bit more confusing simply because we have the 4x that we're going to rewrite because nothing's being done with him, but that positive 3 is being distributed to 3x and to negative 2. 3 times 3x is 9x. 3 times negative 2 is negative 6. Rewrite what doesn't change. Make your dotted line. As you look at this, you notice that you've got these two x's on the same side. Simplify them. 4x plus 9x is 13x. Rewrite the minus 6 equals 33. At this point, you might realize you're going to get rid of that 6, so you're going to plus 6 to both sides. You get 13x is equal to 39. We divide by 3 now, and you get x is equal to 3. Sorry, you divide by 13, not by 3. I was thinking of the answer, and I wrote down divided by 3 when it's really divided by 13. Yes. This one is similar to number 12, but the difference is that you are distributing the negative 5. Rewrite that 3x, so you have 3x. Negative 5 times 2x is negative 10x. Negative 5 times 3 is negative 15. Equals 20. Make the dotted line so you can see both sides. We distributed already, D. I'm going to write some steps that might help you for these. Distribute. The next step is to combine like terms. When you combine 3x minus 10x, because they are like terms, we get negative 7x minus 15 equals 20. I always say, let's rewrite things that don't change. And then the last step is to solve, which is basically to undo what's being done. So we're going to add the 15 to both sides, rewrite what doesn't change, negative 7x equals 35. We're going to divide by negative 7. X is equal to negative 5. So distribute, combine, rewrite, and solve might be steps that you may want to use to make sure that you understand which steps to follow if you get stuck. Ask for the area of a triangle. How do I get the area of a triangle?
You times it and then you divide it by 2.
Yeah, it's 1/2 base times height is the fancy formula, but it's basically length times width divided by 2 because a rectangle is length times width and a triangle is half of that. So this one is going to be the base of 5 times the height of 2, which is 10, divided by 2 is 5, and it's square units because it's area. This one, a basketball court, so I think it's a rectangle, is 29 by 15. They want to know what the area is. So basically all you're doing is 29 times 15. So it is 435, and because it's area, it's meters squared.
Why would it be meters squared? Why is it meters? Oh, because
Should the perimeter or the area be used to find amount of carpet needed for a lounge room? Area, because it's about, yeah, it's the space on the inside. What if I said to find the length of a border around? That would be perimeter. Good. Let's look at this one. This one is another question that causes us some issues, and it's simple because we got to just look at what's the mathematical. So you've got to use your math thinking Do not think this is drawn to scale. Don't think it looks like it is half or it doesn't look like it should be. Use your math thinking. They want to know the area of rectangle B. So that means I need to know what this length is, and I know this height is 5.
How do we know that?
Because if this distance here is 5, then this distance here is 5. Okay? Now, I'm looking to see what the measure of this base is. Now, I know that this guy is 5, and I know that this one is 4, and I know the distance from here all the way to here is 13. So if I know that from here to here is 13, that means I'm using up 5, which is now leaving me with 8, and then another 4, which leaves me with 4. So that means that this part here must measure 4, so that 5 plus 4 is 9, plus 4 gives me the whole 13 up there.
How'd you get 4?
The area of rectangle B is 5 by 4, which is 20 centimeters squared. So this whole thing is 20 square centimeters. And then they want the area of the total area. Well, that means I have to figure out what A measures. And A is 3 by 13, which is 39. So A is 39, B is 20. The composite shape is all of it, like what is composed of it, everything together, which is 59 centimeters squared because it is area. It's telling me that it wants me to find the total area in meters squared. So I know that everything is meters, and my answer is going to be meters squared. It says the figure is not drawn to scale. That's very important because we don't want to assume that we could see something and that measures a certain amount. We have to use our mathematical thinking to make sure that we know that what is shown mathematically with the numbers is what I follow. So with this one, what I have to do first is I need to break it up into different shapes. That's up to you whether you want to break it up into this here and this here, or if you want to break it up into other rectangles that are possible. You could break it up into that top rectangle and that bottom one. That's up to you, but you need to make sure that you're using the correct measurements. If we broke it up to these two little ones down here, the area of this figure right up here is 4 times 3. The area of this rectangle is 4 by 3, which is 12 square meters. The area of this full rectangle, well, if the distance from here to here is 15, and from here to there is 4, the whole side of that rectangle, this here, is 19. That whole side is 19. Now, the length,
18.
I have to look at this here and see that this part is 4, and this whole thing is 6. That means this part's 4, which means what is this part? 2. This part is 2. Again, we're using our math thinking because you may think to yourself that it doesn't look the same size, but it is. Now, 2 by 9 is 38 square units. And then the bottom right rectangle, which is this one here, is 5 by 4, which is 20. And so the sum of all of these is 12 plus 38, which is 50, plus 20, which is 70 square meters. So the other way that you could have done it is if you broke it up into this rectangle and this one here. That would mean that the top rectangle is going to measure 6 by 3, which is 18. Then this other rectangle here is going to be this amount, which is 2, because if this is 4 and this is 6, this part is 2. So it's 2, and then the length of that rectangle is not 15, because 15 is from here to here. This part's 4. So if you think about it, if this up here is 3, that means this is 3. That means this has to be 12. This unit here is 12, But this other 4 makes this whole thing 16. 16 by 2 is 32. And then this last part, this last little rectangle, is 5 by 4, which is 20. And then when you add up 18, 32, and 20, you still get 70 square meters. Okay?